Hi, my name is StevenBrown. I am a member of the Sandia National Laboratories Clinic for 2015, and this video presents my completion of Milestone 2. My Milestone 2 is to verify the ability to send and receive data over the USB communications line that was previously set up in my first milestone. So the way that I to verify being able to send and receive data is by creating packets in order to carry data across the line and then check the packets to make sure that the data is valid. So in here, this is the firmware that has been written for the USB communications for this milestone. We'll see that I have defined a prefix and a suffix. And so when a packet is sent across, it will be created according to this structure. It will have a prefix, and then for this example, it will have 8 bits worth of data, and then it will contain a suffix. The way that I do this is by creating a pointer to this type of structure to an array that is returned by the receive data instruction in the USB API provided by TI. So if we go through here, what happens is the USB gets set up, and this is example code that was taken from TI but modified to what I wanted it to do. Basically what I did was combined my previous example of being able to blink an LED now with this packet protocol. The previous example took in 1 bit at a time and processed 1 bit at a time, but this allows us to send a whole packet worth of however many bytes we want, up to 1 kilobytes, which is what we will be using for the final application. So we'll see here that this firmware tells us that it will send across the USB to tell us to enter a valid number between 1 and 5, because this example has 5 options which are seen here. We'll be able to turn the LED on, off, toggle it slow, medium, or fast. And the way that this works is by converting this string into an output and sending it across the USB using this function provided by TI's API for the USB communication. Then we use a command called USB CDC, because this is a communication device class example, to receive data that will get stored into an array called a buffer, which was previously defined, and it will contain 3 bytes, and this is set as to which virtual COM port the USB will connect to. So down here, once we have received this, we automatically, according to this pointer, know that the suffix will be the 3rd byte from this buffer, the prefix will be the 1st byte, and the data will be the 2nd byte. So we can go down here and we use this pointer to point to the prefix of our data of the packet to check if it's the prefix set in this instruction, which this prefix is a 3 or a hexadecimal 39, which is the equivalent of the ASCII value 9, and we'll see that as we go through this example. Then the data, then we also check the suffix of the incoming packet to see if it matches the suffix that we expect. If these two checks are valid, then we'll move into the example. This first step is to subtract hexadecimal 30 from the data from the packet so that we can then just use the numerical value essentially. So then I go through and I check to see whether the data was a 1, a 2, a 3, a 4, or a 5, and respond appropriately. Now, if the prefix and the suffix are not correct, then we have an else statement saying that there is an invalid packet structure. this else right here tells us that the data was not a 1 through 5, and so that command doesn't exist. But if the prefix and suffix aren't correct, then we have an invalid packet structure, and this will require the host to resend a valid packet structure. So I'm going to pull up what's called real term, and essentially it's going to allow us to look at the sending and receiving. So I have this connected to port 7, which is the virtual COM port created by this application. I set the baud rate, and there's no parity. There's going to be 8 bits and 1 stop bit. I'm going to close that for now. And then I've set this up already so that we will send the prefix byte, which is a 39, the ASCII value of 9, then a 1, which will tell the LED to be on, and then the return this 0D, which is our suffix value. So I'm going to come back into here in the project. I'm going to build this. Now that it's finished building, I'm going to run it, and then I'll pull up this COM port, and we should be able to see this. Oh, we've got to open up the port, open it. We'll send this across, and we should be able to see that the LED is on, which we do. Now I can go through and I can change this, and I can do a 2, that will tell me it's off. Do a 3, it's toggling slowly. I can do a 4, toggles medium. I can do a 5, that will toggle fast. Now if I send a 6, remember we have to enter a 1 through 5, so a 6 shouldn't work. I send that and it tells me no such command, try again. So I can change that back to a 1, say to keep the LED on. But if I change this, for example, to a 3.8 hex, and I send that across, then it tells me that there's an invalid packet structure, try again. So now we can see that we can validate data coming across, and if it's valid data by checking the packet according to the structure, then we can use that data. For the final application, what will happen is we will validate packets, 3 different types of packets. One type of packet will be used to set the current, which node of the 32 nodes in our project will be set to the current value, which node of the 32 nodes will be set to the ground value, and then we will have a packet coming in from the host as well, telling us what the value of the current source should be. And these are the 3 packets coming from the host. Then the packet going from the microcontroller to the host, from the device to the host, will be a packet that contains essentially 1 kilobytes worth of data, the maximum amount of data that we can send across the USB line. And each of these different types of packets will have their own prefixes and suffixes, and that way we can check to make sure that we know which packet it is and that it's a valid packet before we use the data. If it's not a valid packet, then we'll have to re-ask for the data to be sent again. And that is my verification of Milestone 2. Thank you. Oh, gotta open up the port, open it. We'll send this across, and we should be able to see that the LED is on, which we do. Now I can go through and I can change this, and I can do a 2, it will tell me it's off. Do a 3, it's toggling slowly. Do a 4, toggles medium. I can do a 5, that will toggle fast.